Rigging is the use of ropes and other equipment to take down trees or remove limbs. Rigging is necessary when free falling is not possible due to potential hazards such as obstacles below or power lines. Rigging techniques often allow the climber to remove larger limbs in less time and with more control.
The basic tools and techniques of rigging are described in this chapter. However, it is emphasized that only experienced climbers should attempt to use these techniques. Rigging is the most advanced aspect of working in a tree. Even for veteran climbers, it is always best to practice new techniques in open areas so that safety and control will not be in question on those trees where experience counts. The tools and techniques used in rigging vary with the situation. If removing limbs from a tree that is being pruned, care must be taken not to damage the remaining branches and trunk. If rigging for removal, the climber has more options in how to work the tree. The simplest form of rigging involves the use of ropes, wraps on the trunk, and natural crotches used as rigging points. More sophisticated techniques require a better understanding of the advantages and limitations of the equipment and methods involved.
This computer-based training module is an educational tool for introductory level arboriculture. It may be used as part of, but not as a replacement for, a comprehensive training program. While some equipment and techniques are explained and demonstrated, actual use requires knowledge of and experience with them prior to use in an actual work environment. The techniques described or depicted in this CD-ROM must be analyzed and at times modified to meet the specific needs of the individual situation. Be sure to understand the proper use of all equipment required and use safe work practices at all times. Familiarize yourself with local, state, provincial, national, or federal government standards as applicable to the job assignment and requirements. Take advantage of the other sources of information and training from the International Society of Arboriculture. 1. Be able to define rigging terminology and identify techniques. 2. Identify pieces of rigging equipment and their applications and identify the limitations of that equipment. 3. Identify the proper application of various rigging techniques and how they improve safety and efficiency in lowering limbs. 4. Select the most appropriate cutting techniques for different situations. Rope may be considered the arborist's most important tool. The characteristics of a rope, strength, stretch, durability, etc., are the result of the materials and techniques used to make it. To date, polyester is the material most widely used by arborists, and most commercially available climbing and rigging lines are made from this fiber. Nylon has high strength, stretch, and energy absorption, but tends to lose strength when wet. Natural fibers are not generally as strong as the new man-made fibers and can rot over time. Newer fibers such as Kevlar show some promise but have not been widely developed for arborist rigging applications. Many types of ropes are used in arborist rigging. Three-strand rope has relatively low strength and high elongation and is relatively inexpensive. It is appropriate to run through natural crotches for climbing or rigging, but it also runs well through a false crotch. A major drawback to three-strand rope is the twisting or hockling that occurs as the line is used. 16-strand braided arborist lines have relatively large cover strands for strength and abrasion resistance and a parallel core to keep the rope round and firm under load. In this construction, the core does not carry the load. A 12-strand rope is braided rope without a core. Tightly woven, solid braid, polyester blend 12-strand lines are a popular choice for natural crotch rigging. Loosely woven, hollow braid polyester 12-strand rope is often used for rigging slings, but would not be appropriate as a rigging line. The number and diameter of the strands compared to the diameter of the rope determine whether the lines can be spliced. They also determine abrasion resistance and whether the rope remains round. Double braid lines are just that, a rope inside a rope. The core and cover are balanced and share the load almost equally. For this reason, they are not recommended for natural crotch rigging, where the friction of the cover with the tree causes an imbalance in the load taken by the core and cover braids. It is an exceptionally strong and low stretch line, but should be run only over the smooth sheaves of a block or pulley or the bollard of a friction device. Kernmantle rope, literally meaning core and cover, is adopted from recreational rock climbing and has a very tightly braided cover to protect the load-bearing core from abrasion. Such ropes are not often used by arborists. Understanding the design and limitations of each piece of equipment employed, as well as the tree itself, is an important part of setting up a safe and efficient rigging system. Too often, arborists fail to think through the forces and loads that might be involved in rigging out large limbs. The failure of any link in the system can have disastrous effects, including property damage, injuries, or even a fatality. Few practices in arboriculture are as involved or as inherently dangerous as rigging. Professional knowledge and experience are essential. The tensile strength reported by the manufacturer is the breaking strength of a rope or piece of hardware. As a rope is used, its strength is reduced due to dirt, wear, knots, and, of course, loading. Cycles to failure must also be considered. One cycle means one lift or drop for a rigging line. Each cycle creates permanent damage in the rope, and eventually the rope will fail. At larger loads, this number of cycles to failure is reduced. If the load in a rope is equal to its tensile strength, the rope may fail when used only once, one cycle to failure. To increase the life of a rope, a working load limit, WLL, much less than the tensile strength, must be established, and workers must ensure that the loads in each cycle are less than this WLL. It's important to understand that the load on the line may be much higher than the actual weight of the piece being removed. The design factor, sometimes called safety factor, is the tensile strength divided by the WLL. For arborist rigging with dynamic loading, high wear, and dirty conditions, a design factor of 5 or greater is often chosen. For example, if the published tensile strength of a piece of equipment is 20,000 pounds, then the WLL will be 4,000 pounds for that tool. Keep in mind that the load on the equipment is often many times higher than the weight of the log. Various components of any rigging system have different working load limits, and it is important to consider each component. Arborists generally design rigging systems such that the rigging line is the weakest link in the system, and all equipment used is within the working load limit of the rigging line. Choosing the correct equipment for a given situation can make the job much more productive and safer, provided the science behind a given device is understood. The demands placed on arborists' equipment by dynamic loading and abrasion means that tools from other industries are not always applicable to the tree care.
Arborists rely on friction to help control loads when lowering branches out of a tree. Historically, rigging lines were wrapped around the trunk of the tree to add some friction. It takes experience to get this right because not all trees are alike, and carrying arms full of rope around the tree has never been much fun.
Friction devices have been designed for tree work, and they have some obvious control advantages over taking wraps around the tree. Examples of friction devices include the various designs of bollards, which are posts that strap to the tree for taking wraps in a load line. The large diameter of bollards provide a favorable bend ratio, which minimizes strength loss in the rigging line. Some bollard-type lowering devices are designed with a ratcheting system that allows the arborist to remove slack from the line or even lift a load. Other friction devices have been designed for smaller loads. The bend ratio is the ratio of the diameter of a branch, sheave, or other device to the diameter of the rope wrapped on it. In this illustration, the bend ratio is 4:1, which is the minimum desired ratio. Rather than having to tie a knot each time a rope is used, connecting links such as carabiners, shackles, or screw links can speed the process. Most connectors are not designed for dynamic loading, which eliminates their use in most trunk and top removal operations. Because connecting links could be the weak link in a rigging system, their use should be minimized, and arborists should avoid connecting multiple links together. While aluminum is preferred for climbing because of its light weight, steel has far better strength and fatigue properties. With high loads, many loading cycles, and the potential for dynamic loading, steel connecting links are usually the preferred choice in rigging. Carabiners must always be loaded along their major axis and never across the gate. Selecting the correct shape can aid in keeping rope and other devices properly positioned in the carabiner. Common shapes for carabiners are oval, D, modified D, and pear. Some have a fixed eye in addition to the opening formed by the gate, similar to a locking rope snap. The hitch used to attach a carabiner to a line should be such that it prevents the carabiner from rolling and side-loading. Most of the time, carabiners are best used for climbing and avoided for many rigging operations. Compared to running lines through tree crotches, the use of blocks can decrease dynamic loading, wear on ropes, and damage to the tree. The rotating sheaves of blocks and pulleys can be mounted with bearings or bushings to reduce friction. Bearings have lower friction but are more susceptible to damage from dirt, and they are not considered as strong in dynamic loading situations. Thus, most arborist blocks are made with bushings, while rescue pulleys may have bearings or bushings depending on their intended use. When using a block in a tree, it is important to keep in mind that the load at the point of attachment of the block can be double the load in the rigging line. Arborist blocks are heavy-duty pulleys with a large rotating sheave for the lowering line and a smaller sheave to accept a rope sling. These devices are designed specifically for arborists and are descendants of large industrial snatch blocks. Most significantly, the side plates of an arborist block extend beyond the sheave to protect the line from abrasion. In contrast, rescue pulleys are designed for static, overhead rigging, where the loads are known and very low friction is required. Pulleys require a separate connecting link to secure them to the rope, sling, or other equipment. Lines or slings should never be attached directly to the pulley side plates. Through knotting or splicing, rope can be made into any number of tools. There are many variations of slings and other rope tools used in rigging. In addition, webbing slings can be purchased in differently sized sewn loops, or they can be knotted from tubular webbing. The strength of a sling depends on the material, the way the loop is formed, sewn or knotted, and the way the loop is used. For example, if the strength in a straight pull is 100%, then a choker application, girth hitch, retains about 80% of that strength, and a basket hitch, where an object is cradled in a bight by both legs of the sling, is twice as strong.